Okay, so we're looking at trying to mix this acetone and shellac up, and it's not going very good. Um, and so, and I'm gonna have to. I still don't have enough hands. Hang on. And then, yeah. Okay, so what I've done is I added Everclear, plain old grain alcohol, to my shellac mix. So it's half grain alcohol and half shellac. And I'm going to let that sit. And we'll see what happens because it's already dissolving better. I added that alcohol and it mixes with the acetone right away. Um, and probably what I need to do is chop it up or something better. I think they talk about shredding it or something. But this is experiment numero uno. So, the other thing is I can always make a little more. I got a pound of this stuff. And, a bottle or so of acetone. Nail polish remover. So acetone is really, really, really polar because it's got a bunch of hydroxyls and I think 6 carbons or something. Um, and those hydroxyls can go either way. They can be a cation or an anion just by switching sides, an OH or an HO. And so this stuff dissolves um, the shellac. The shellac is an organic crystal, right? And the stuff, the active ingredient in there that makes it stick together is just cellulose. And the brown stuff is lignin. It's what makes wood hard. See the color? How about that? So, and it's from bamboo, actually, which is, it's brittle, but it's very, very, very hard, much harder than like oak or mahogany even or something. I mean, not mahogany, teak, that sort of thing. We've got a tree here in Arizona called ironwood that is, I believe, the hardest wood on the planet. And it's not as hard as this bamboo tip that I have here because I added this stuff to it and it's soaked in. And now it's held together as a bioplastic that's stronger than steel. Weight for weight, it's stronger than steel by many times, and it's damn near stronger than steel just size for size. Pretty strong stuff. And this is how you make it. Just this is like a sliver of bamboo, and I just sprayed some on it. But if I soak bamboo in this stuff, it goes all the way through the wood. And instead of having just a brittle piece of wood that, when it's dry, that's real hard, I have a sort of semi-flexible piece of biological plastic that you can make as strong as steel, because when I take this out of the mix there, I can put it in a slow oven and heat it up to about I don't know, 150 degrees Celsius, something like that. Maybe not quite that much, 120. Over the boiling point of water, but not much. And then I cool it down. And I can do layer after layer after layer if I have to. And they're thin. They get molecular thin. And it will develop double covalent bonds when I add the AUPT dust into this. And then it will really truly be stronger than steel.